Welcome back to another video. Today we will learn about how quicksort algorithm works and what is the intuition behind this algorithm. So this algorithm works on an array. So let us assume that we have an array of, let's assume some random elements like 40, 30, 20, 10, 50 and 60. So in this algorithm we have three pointers. First is pivot. So let's assume that pivot will always point on the zeroth element of the array, right? So this is the pivot, and our I index will start from next to the pivot, which is I plus 1. So let's put the index 0, 1, 2, 3, 4 and 5. So I will start from the point next to the pivot, and j will start from the end of the array. And let me just try to explain what I will search for and J will search for. So I will search for the elements greater than the pivot. So I will move until pivot is smaller. Okay, and J will search for the elements smaller than the pivot. Right. So J will move until pivot is greater. Okay, so J will be plus plus and I will be minus minus. Okay, minus minus. So J will search for the elements smaller than the pivot, and I will search for the elements greater than the pivot, right? So let us start. So is this greater than pivot? Of course it's not. So it will move to 20. Is it? It's not. So it will move to 10. Is this greater than pivot? Of course it is. So it will move. I will move here. Okay. Now J will start searching for the elements smaller than the pivot. Okay. So J will move here. It's not smaller than the pivot. J will move here. Okay. So this is smaller than the pivot. So J will come here. Now what will happen? As now I is greater than J, right? So what will happen? We will have a condition where we need to swap this element with the pivot element. We won't be swapping I and J now, right? So 40 will come here. So our output would look something like this: 10, 30, 20, 40, 50 and 60. So we'll swap the j and the pivot point, as I has surpassed the j and now I is greater than j, right? So now what will happen? Our this element is sorted, right? Now we have to sort this left half and the right half. So we have to sort left half and the right half. Okay. So we will call recursively quicksort on this and this. So let's first solve this. So let us assume that in 10, 30 and 20, this is our pivot. Okay, and this is our L low and this is our high. Or let's assume, let me just erase this. Let's assume that they are I and J. So this is our I and this is our J. So is this greater than 10? Of course it is. So our I will point here. Is this smaller than 10? It's not. So it will move. Is this smaller than 10? It's not. So J will come at P. Now what will happen? Pivot will swap with J, which is it will swap with itself. Okay, so 10, 30 and 20. Now you can see that this is sorted, right? And on the left we do not have anything. On the right we have two elements which we need to sort. Now we'll call recursively quicksort on these two elements. So we'll call our 30 and 20. So pivot will be at this and I and J will be here. So is it greater than 30? It's not. So it will move. And is it smaller than 30? Of course it is. So what will happen? We will swap pivot and the J. So it will swap like this 20, 30. So this left half is sorted now. Now what about right half? So 50 and 60. Our P will be here. Our I and J will be here. So we will check if we will check if is it greater than 50. Of course it is. So I will be here. And is it smaller than 50? It's not, so j will move here. Okay, so remember that we always swap pivot with j, not with I. If I is greater than j, only in that case, right? So what we'll do here, we'll swap it with itself. So means it's already sorted. And if there is only one element, we do not call recursive function. So like this we have sorted the whole array. So our last would look like 10, 20, 30, 40, 50 and 60. So yeah, this is sorted in ascending order. So let me take some other example so I can explain this better. So let us take this example: 50, 30, 20, 10, 40, 80, 90, 60 and 70. So let us run quicksort on this array. So our pivot will be at this point, right? I will start from the next point to the pivot, which is 30. So let me put the index of this elements 0, 1, 2. So I will start from the point next to the pivot and j will start from the end of the array. I will search for the elements which are greater than the pivot. J will search for the elements smaller than the pivot. So is this greater than the pivot? It's not. So I will move. Is this greater than the pivot? It's not. So I will move here. Is it greater than the pivot? It's not. This is the pivot. So I will move. Is this greater than the pivot? It is. So I will move here. I will be placed here, right? This is our I. Is this smaller than the pivot? It's not. So J will move. Is this smaller than the pivot? It's not. So it will move. Is this smaller than the pivot? It's not. So it will move here. Is this smaller? It's not. So it will move here. So our J will point here. Okay. I will be here and J will be here. As you can see that our I is greater than J. So what we will do, here is the condition. If I is greater than J, so what we will do, we swap j with pivot. We won't swap I and j. Let me just try to first clear this. So yeah, so we will swap j with pivot. Okay, so we will swap this and this. Okay, so our output element would look something like this, which will be 40, 30, 20, 10, 50, 80, 90, 60 and 70. So as you can see, our 50 is at sorted position. The elements which are on the left side of the 50, or you can say the pivot or the j element, are lesser than the pivot, and the elements on the right side of the pivot are always greater than the pivot, right? So this is, he is in the sorted position, as you can see. Okay, so let us call quicksort recursively on the left half and the right half. So first let's take an example of left half. So 40, 30, 20 and 10. Pivot will be here. I will start from the pointer next to the pivot. J will start from the last of the array. Okay. So I will search for the element greater than the 40. Is this greater than 40? It's not. So it will move. Is this? It's not. So it will move. Is it? It's not. It will move. And is this smaller than 40? Of course it is. So we will swap this with 40. Uh, what will happen? As you can see that our I is greater than J. So what will happen? We will swap it with pivot. So 10, 30, 20 and 40. So 10 is at sorted position. On left side we do not have anything. On right side we have these three elements, right? So we will need to call quicksort on these three. So 30, 20 and 40. So our pivot will be this. I will be here. J will be here. Is this greater than 30? It's not. So it will move. Is this greater than 30? It is. So I will be placed here. Is this smaller than 30 or pivot? It's not. So is this smaller than 30? It is. So J will be moved here. Okay. Now what we'll do, as I is greater than J, we will just swap 30 with 20. So we'll do 20, 30 and 40. So we have swapped with pivot. Okay, so as you can see, this is also sorted, right? 20, 30, and 40. So our left half is sorted 10, 20, 30, and 40. What about right half? So let me just, yeah, what about right half? So let us assume that these are the elements 10, 90, 60, and 70. This is our pivot. This is I. This is J. We will keep on moving I until we find the greater. So is this greater than the 80? Of course it is. So I will stay here. Is this smaller than 80? Of course it is. So J will stay here. Okay. So now what we will do, as we have find I which is greater than pivot and J which is smaller than pivot, but I is yet smaller than J, right? So we will swap this I and J. Okay. So 80, 70, 60, and 90, right? So our I, after swapping, what we will do, we will do I plus plus and J minus minus. So J and I both are here and pivot is still here. Okay. So now please tell me that if, so now uh, is I greater than 80? It's not. So I will move here. Okay. Is this greater than 80? Of course it is. So I will be here. Now is J smaller than 80? Of course it is. So I will stay here. Okay. So now what we will do, as I is greater than J, I has surpassed the J index. So what we will do, we will swap it with the pivot element. So let's swap now 60, 70, 80, and 90. Now as you can see, our right half is also sorted. So our whole uh, array output would look something like this, which is 10, 20, 30, 40, 50, 60, 70, 80, and 90. So we have the whole sorted array. So let us go through the code now. Okay, let me just show you the code. So this is the code. So as you can see, the problem is statement on the lead code, which is sort an array. So for this problem, we are using the quick sort, which we have learned just now. So this is the given array, which is 5, 2, 3, 1. We have to sort it in ascending order in n log n time. So also one more thing, that the time complexity for this will be n log n. Why? So why? Because, so as you can see that when we discover the pivot point, we divide this array into two parts, which is left half and right half. Then after dividing it, we recursively call quicksort again. So we again select the pivot point. Let's say if it's 20, then we again divide it into two half, right? So even if we divide it into multiple halves, we have in four steps, in four partitions, this array will get sorted. So that is the n log n time complexity, right? So let us try to understand the JavaScript code here. So what I've done here is this is the quicksort function where I have passed the array low and high. So low and high, you can imagine it as I and j. So if low is smaller than j, until and unless low is smaller than j, only then we will be calling this functions, right? So const pivot index partition array low high. So we have passed a partition function where we will be partitioning the array. So here you can see that we have set pivot as array of low. Okay, so the lowest index will be the pivot point, as we have seen in the example, and I will start from the next of the pivot point, which is low plus 1, and j will start from the high. Okay, so it will be moving from backward to forward. So while I is less than equal to j, only then we will be entering this loop. So until array of I is smaller than pivot, keep on moving I plus plus, right? And until array of j is greater than pivot, keep on moving j minus minus. So it will find the element which is smaller than pivot, and I will find the element which is greater than pivot. So if I is smaller than j, only if I has not surpassed the j, we will swap the positions of I and j, right? And we will do I plus plus and j minus minus. Now, after this, if I has surpassed the j, what we will do, we will swap it with the low, which is the pivot point, right? This one. So we will swap low with j. like this, and we will return j. So why we are returning j? We are returning j so that we know what is the left half and the right half, and we can call that quick sort recursively on left and right half. So here you can see we have the pivot index, which is the j point. We call the quick sort, we pass the array, we pass the low, which is the left half, and pivot index -1. So we don't need to include the pivot point, which is in this already in the sorted position. So we don't need to include that. So we pass, this is the left half for the left half, and this is for the right half, where array pivot index +1, because we don't need to include the pivot point, and the high, whatever high is. And then on the above, we just call this quicksort function, passing the array 0th index and nums dot length -1, and return nums. So as you can see, if I submit this code, so yeah, it is running. Great. Yeah, that's it. Thanks.